Now, if you've ever felt the need to flex on people, let you know some math, one sign I've seen students use the most is this sign right here. But what does this sign mean? Well, it's called a radical, and it's used to signify something called a square root. It's called a square root. But why is it called this? Well, let me give you an example. Let's say, for example, I had a square. So remember how we called it a square root? I want to tell you exactly why it's called a square. So let's say, for example, the area of this square is 16. And so I want to find out what the length of each side is. Well, because it's a square, I know from my previous knowledge that a square is simply the length times the width, but the length times the width are the same. So here, I'm going to put x on the top and x on the side as well because the length and the width in a square are exactly the same. So I know that x times x is 16. And I also know that x times x, that's x multiplied by itself 2 times, which is x squared, x to the power of 2. Well, I start thinking about what would be a good solution for x. What could I plug into x so that x squared is equal to 16? I know after trying out a couple numbers that the answer should be 4. Because when I set x equal to 4, I know that 16 is equal to 4 times 4. So as a result, I find that x is equal to 4, and I know that 16 is equal to 4 to the power of 2. But because 16 is equal to 4 to the power of 2, I'm going to introduce this radical that I just showed by writing that root 16 is equal to 4. Once again, because 4 to the power of 2 is 16, root 16, the square root of 16, is equal to 4. Basically, the square root is the opposite of the square. I have the square already. I'm trying to find out what number I can multiply by itself to get the number that's inside this radical. Let me give you a couple more examples to show you exactly what I mean. For example, let's say I had the square root of 9. What's this equal to? Well, I know 9 is equal to 3 to the power of 2, because 3 times 3 is 9, so that's why the square root of 9 becomes 3. So I multiply 3 by itself, and then I get 9. In the same way, root 4 is 2, because 4 is equal to 2 times 2. 2 to the power of 2 is 4. So because I can square 2 to get 4, I square root 4 to get 2. Notice I'm going the reverse order. And finally, root 25, the square root of 25 is equal to 5, because 25 is equal to 5 to the power of 2. I square 5 to get 25, so that's why I square 25 to get 5. In this way, I'm reversing the process of squaring to get the square root. Whatever I square in one direction, I square root in the other direction. Keep that in mind as we solve more problems. Let's look at an example problem to round it out. We have here Melanie, who sees the question, square root of 9 is equal to x, and she correctly writes x equals 3 because 3 to the power of 2 is equal to 9. She says here 3 squared is 9, so that's why when we have square root of 9, which equals x, we can find that x is equal to 3. Nice job, Melanie, you got that correct, because you're right, that square root of 9 is indeed equal to 3. She sees another question that says x to the power of 2 is equal to 9, which asks her to find x. It seems kind of similar, so Melanie writes x equals 3 again. Is she correct here? Well, before I go into whether or not she's correct, let's look exactly at what she's saying. She has the square root of 9 is equal to x, and we know here that the square root of 9 is equal to 3, as 9 is equal to 3 to the power of 2, which is 3 squared. So as a result, because 3 to the power of 2 is 9, and the square root of 9 is 3, as a result, x is equal to 3. Simple enough. Melanie got that. Nice job, Melanie. Now, let's look at this other situation. All we have here is x to the power of 2 is equal to 9. We're not given a square root here. And we're trying to find x as a result. So, I can use x equals 3 again. When x equals 3, 3 times 3 is equal to 9, so that's correct. So, Melanie wrote that x equals 3, which is good. The problem here, though, is that when I plug in minus 3 for x, I notice that minus 3 times minus 3 is also equal to 9. Once again, when I plug in minus 3 into x, minus 3 times minus 3, the negatives cancel each other out because negative times negative is positive, and that becomes 9 as well. That's a really tricky situation. So that kind of tells us that there's a little bit more to the situation than we might think. Negative numbers might make things more complicated. For now, I want you to pay attention to the concept of the square root. And next lesson, we're going to go into more detail on what these negative numbers might mean. For now, I want you to focus on mastering this concept that the square root is the opposite of the square. So, in conclusion, Melanie is correct, but she's only partially correct. When she writes x equals 3, that's half of the correct answer. She should have written x equals 3 and x equals minus 3 as well. There's more than one correct answer here, and she needs to get both to get full credit. We learned some new vocabulary today, and we're going to use this moving forward. The square root of a number, x is any number when multiplied by itself that equals x. So basically, the square root is any number where if you square it, so if you multiply by itself, it becomes that original number. Finally, the square root is represented by a radical. This really cool sign we have right here is called a radical. When I refer to the radical in the future, make sure you know that it refers to this sign. Lastly, to review what we just covered, when asked to find a square root, find what you need to square to find the number inside the radical. So, once again, when asked to find a square root, you got to figure out what you need to square to find the number inside the radical. For example, root 16 is equal to 4 because 4 to the power 2 is equal to 4 times 4, which is equal to 16. Finally, negative square roots are square roots as well. And I don't want to spoil the rest, so I'm going to save that for the next lesson. Really, to recap, basically a square root is the opposite of a square. Think about what you do to square a number. So you're multiplying the number by itself, finding the power of 2 of the number, and just go the opposite order. Find out whatever number you have to multiply by itself to get the number that's inside the radical. That's your square root. For now, see you next time. Best of luck on the problems. Take care.